Here's problem 2.13. A ball thrown vertically from ground level is caught 3 seconds later by a person on a balcony, which is 14 meters above the ground. Determine the initial speed of the ball. Alright, so we have a ground level here, and we have somebody throwing the ball like this with some initial velocity, which we don't know. And the ball is going to go up. It may go up to maximum height and come down, or maybe it's caught along the way. We're not really sure. But there's a balcony here, and there's somebody here who's going to catch this ball on the balcony. What we do know is that the time is going to be 3 seconds. We know our initial velocity is going up, so we'll define up as our positive direction, even though we don't know what the value of that velocity is. But if we define up as positive, that would make our acceleration, which is the acceleration of gravity, and gravity is always down, is going to be a negative 9.8 meters per second squared, which makes sense because if we throw this thing upward, it's going to decelerate as it's going upward. Alright, and we know that eventually it's going to be caught at 14 meters above the ground, so that's going to be our displacement delta y, 14 meters. So strictly speaking, we're going to have a displacement delta y of 14 meters. And how it got to that point won't matter, but that's just our final minus initial position. So it may have gone through an arc, or it may have just gone straight there. We don't know. We might be able to find that out later. Alright, so we've got 3 kinematic variables given and a fourth one asked for. So it looks like we should decide our equation based on these 4 variables here. Alright, so we have delta y is equal to initial velocity times time plus 1/2 acceleration times time squared. We want to solve this for initial velocity. So we have that initial velocity times time is equal to delta y minus 1/2 acceleration times time squared, or our initial velocity is delta y minus 1/2 at squared divided by time. So that is going to be 14 meters minus 1/2. Acceleration is a negative 9.8, and t is 3 seconds squared over 3 seconds. So we're going to have a negative negative, which will give us a positive there. And what do we have? I have 19.37 meters per second. So that was our initial velocity when we threw the ball. Nice to know, and that's the answers to the problem. But I'm kind of curious, was the ball going up or was it coming down when it was caught? I just want to know whether it went through that arc or whether it went just straight there. One way we could do that is find out what our final velocity was. Our final velocity should equal our initial velocity plus the acceleration times time. We just found our initial velocity. It's 19.37, and our acceleration is a negative 9.8, so this can be minus 9.8 times 3 seconds. So what does that give us? A negative 10.0 meters per second. So when it's finally caught, it's moving at 10.0 meters per second, but the negative means it's going opposite the direction of what we define as positive. We said everything positive was going up, so this final velocity is actually coming down, which means that the trajectory of this ball probably went up and then came down like this to the balcony, rather than going straight there or caught on the way up. It probably went to maximum height, came down, had a velocity that was going down when it was caught.